Let's see this. We have this paper, October November 2024, paper 4, variant 2. Please, every one of you, paper निकाल लो ज़रा. Please take out this paper, bhai. Take out this paper. चलो, let's see this. बहुत easy करके देखते हैं paper. चलो. You have some constant, you have some formulas as usual. Let's see this first question. Let's zoom out a bit as well. Or zoom in. Chalo. Let's see this question. A metal wheel, perfect, consists of an axle, 8 spokes, and a rim. Perfect. So this is a metal wheel, 8 spokes, and a rim as shown in figure 1.1. Perfect. Point X is on the rim at the end of one of the spokes. Perfect. Point X is on the rim at the end of one of the spokes. ठीक है. Very good. Very good moment. यही लगना है यहाँ पे. The rim has a radius of this. Perfect. Rim का radius ये है. The wheel is rotating clockwise with an angular speed of this. Perfect. So basically, what are you given? You are given the radius and you are given the W. Can you calculate the speed? Yes, V is equals to RW. V is equals to R, that is 0.85, into the W, that is 140. Can any genius tell me the answer by 119 आ रहा है? Yes, 119 ही आ रहा है. Very good. Everyone else also calculate by 119 or 120 ms minus 1 to two significant figures will be your answer. You have to now calculate the centripetal acceleration. Yes. How can we calculate the centripetal acceleration? Centripetal acceleration has three formulas. You can use either one of them. RW square is what I am using. R is 0.85 and W is what? 140 ka square. Can anyone again tell me the answer here? Can anyone again tell me the answer here? 1.7 into 10 raised to the power of 4. 1.7 into 10 raised to the power of 4 is your centripetal acceleration. Simple. Let's further move ahead. There is a uniform magnetic flux density of 0.18 Tesla into the plane of the page. So you have a B value of this. Perfect. State Lenz's law of electromagnetic induction. Okay, what does Lenz's law of electromagnetic induction state by? Lenz's law of electromagnetic induction, what does this state? Lenz's law of electromagnetic induction states that the direction of induced EMF is such that it opposes the change causing it. You can write it here, direction of induced EMF. Direction of induced EMF is such that it opposes the change causing it. Perfect. ये लिखना है आपने. या ये हम एक्सप्लेन करते हैं. ठीक है, डोंट वरी अबाउट दिस. एक्सप्लेन करते हैं लेंसेज लॉ को. डोंट वरी अबाउट दैट. State the time taken or show the time taken for point X to complete one revolution is this. You have to calculate time period. What can you do? You know W is equals to 2 pi over T. Do you have the value of W, by? Do you have the value of W? Your W की value is 140. Perfect. Place 140 here. 140 is equals to 2 pi over capital T. Time period comes out to be what? 2 pi over 140. That is equals to 45 into 10 raised to the power of minus 3, which is equals to 45 milliseconds as your time period. Nothing complicated. Literally everything is a piece of cake in this paper. Abhi tak everything is a piece of cake in this paper. Chalo bhai. Let's further move ahead. आगे बढ़ते हैं. Calculate the magnetic flux cut by a spook AX during one revolution. Okay, you have to calculate magnetic flux. How can you calculate magnetic flux? Very easy. Magnetic flux is equals to magnetic flux density into area. What is your magnetic flux density? 0.18. Perfect. What is your area? Yep. What is your area here? This is a circle. So you can calculate the area using which formula? Pi r square. pi r square. So you can do that. Multiplied by pi into the radius, that is 0.85 ka square. Can anyone calculate the magnetic flux by? Can anyone calculate the magnetic flux? Magnetic flux comes out to be 0.41 Webers. Simple as that. Determine the magnitude of electromotive force. You have to determine EMF now. अच्छा ये चैट में किसका सवाल है एक सेकंड सर विच ईयर फैजान दिस इज 2024 October November variant 2. EMF is equals to what by? EMF is equals to N into change in phi over change in T. Okay, what is your N here? What will be your N here? Obviously, your N will be 1 because there is one coil only. What is change in phi? 0.41. What is your time period? 45 milliseconds. 45 into 10 raised to the power of minus 3. What does your EMF comes out to be? 9.1 volts. Simple answer. Literally nothing complicated. अभी तक कुछ complicated नहीं है इसमें. Now, let's move on to part 5. Here I will explain Lenz's law in great detail. Just focus on the board, okay? Here I will explain Lenz's law in great detail. Use Lenz's law, okay? You have to use Lenz's law to explain whether the potential is A at whether the potential is higher at end A or end X of this spook, okay? बेटा आपने Lenz's law use करना है and you have to tell whether the potential difference is higher at point A or at point X. So we will apply Lenz's law here भाई. Lenz's law apply करना है किस तरह करेंगे? 1 second, I need your undivided attention here भाई. Lenz's law apply करना बेटा A star students को ही आता है सिर्फ A star students को आता है. Other students just keep on wondering ऊपर force लगेगी नीचे force लगेगी. They are literally confused till the exam day. So Lenz's law only किन लोगों को लगाना आता है भाई? Lenz's law can only be applied by students who are about to score an A star. This is an A star level thing. Please, I want your undivided attention on the board. So, what is written? The wheel is rotating clockwise. Okay, तो wheel clockwise इस तरह rotate कर रहा है. Perfect. Wheel clockwise rotate कर रहा है. Now, according to Lenz's law, induced EMF will oppose the change causing it. Beta, induced EMF will oppose the change causing it. Induced EMF is being caused by this clockwise motion. Perfect. Induced EMF is being caused by this clockwise motion. What will be the opposite of this clockwise? Anti-clockwise motion. Perfect. So basically your direction of force will be upward. Perfect. Your direction of force is upward. Perfect. एक सेकंड क्या किसी का सवाल है? Lenz's law. Yup. Wahab, very good. Lenz's law will state that your force is acting in the anti-clockwise direction. Perfect. Now, if your force is acting in the anti-clockwise direction, ठीक है, force अगर anti-clockwise direction में act कर रही है, and do you know where is the direction of the magnetic field? There is a uniform magnetic flux density. What is the important word here? Into the plane of the paper. Into the plane of the paper. So your force is acting upwards and you have a magnetic field into the paper like this. Where will your second finger point? Yep. Where will your second finger point by? Where will your second finger point? If you apply Lenz's law here, your first finger is in the direction of the force, or you can say thumb is in the direction of the force. Magnetic field is into the page. Where will your current key finger point? Your current is flowing in this direction. So current is flowing from A to X. Do you agree? यहाँ तक is everything clear to all of you? Current is flowing from A to X. यहाँ तक clear है भाई? Yes or no? सर ये शुरू से समझा दें प्लीज बेटा, ये शुरू से ही तो समझा रहा हूँ, इसमें और कितना डिटेल में हम जाए। देखो 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 देखो, योर रेगुलर मोशन इज इन द क्लॉकवाइज डायरेक्शन। आप रेगुलरली क्लॉकवाइज डायरेक्शन में मूव कर रहे हो, ठीक है। टू oppose this motion you will have an anti-clockwise motion. If you have an anti-clockwise motion, your force is pointing upwards. Your magnetic flux density is into the page. If you apply Fleming's left hand rule, current क्या आएगा? Towards the right. Your current is flowing from A to X. अब आगे बात समझ में भाई। Your current is flowing from A to X. Yes or no? Hmm. Is it clear or not भाई? अभी भी clear है या मसला है अभी भी? Hmm. Current flows from A to X. And if current is flowing from A to X, which one will be the higher potential? X. Current always flows towards the higher potential. This is your higher potential. Perfect. You can write this down. You can say, first of all, you will say applying Fleming's left hand rule. Left hand rule. And if you apply Fleming's left hand rule, what will happen? If you apply Fleming's left hand rule, क्या हो गया, ऐसा क्या हो गया मोमिन, ऐसा क्या हो गया? If you apply Fleming's left hand rule, what will you do? You will take, yeah, assume the direction. This is something, this एक मार्क बेटा उन्हीं स्टूडेंट्स को मिलेगा जिनका ए स्टार आने वाला होगा। वेरी गुड। चलो अल्हम्दुलिल्लाह अल्हम्दुलिल्लाह अल्हम्दुलिल्लाह। सर फोर्स, हाउ डिड वी गेट क्लॉकवाइज वाली फोर्स, एंटी क्लॉकवाइज वाली फोर्स? देखो वहां यहाँ पे क्या लिखा हुआ है बेटा, वहां यहाँ पे क्या लिखा हुआ है? इनिशियली आप ये जो स्पूक है उसको किस डायरेक्शन में घुमा रहे हो बेटा? क्लॉकवाइज डायरेक्शन में। लेंसेज लॉ क्या कहता है? योर induced EMF flows in such a direction that it opposes the initial force. इनिशियल फोर्स अगर क्लॉकवाइज डायरेक्शन में बेटा, तो इंड्यूस्ड ईएमएफ की फोर्स किस डायरेक्शन में होगी? एंटी क्लॉकवाइज, सो अपवर्ड फोर्स। समझ आ गई वहां बेटा? अब यू कैन राइट इट हियर। अकॉर्डिंग टू फ्लेमिंग्स लेफ्ट हैंड रूल, assume the direction of force as anti clockwise or upwards. Perfect. Current flows from A to X, hence higher potential is X. Perfect. Nothing complicated. Acha, so according to Lenz's law, the induced EMF causes the wheel to move in the opposite direction. Yes, 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 yes. Yes, yes, Vanya, very good. Very good, beta. Very good. This is what it actually means. Shabash. Very good. Chalo, let's move on to question 2, bhai. Acha, now read this carefully because this is a marks gaining question. Beta, gravitational field, circular motion, capacitance, and simple harmonic motion, all are marks gaining topic. ऐसा सवाल आए तो you just pay extra attention so that you don't do any errors in calculations as well. अच्छा, you have to define gravitational field strength. That's easy. Very good, Wahab. Force per unit mass. Force per unit mass. I guess I have written this definition in the notes as well. अब देखो भाई क्वेश्चन 2 को पढ़ो। द सन में बी कंसिडर्ड टू बी अ यूनिफॉर्म स्फीयर विद अ मास ऑफ दिस, ठीक है, सन का मास ये है, एंड द सरफेस टेम्परेचर ऑफ दिस। प्लीज प्लीज पे अटेंशन, आहिस्ता आहिस्ता हर चीज को पढ़ो। A probe with a mass of this moves in a straight line towards the sun. Perfect. When it is at a distance x from the center of the sun, the probes measure the gravitational field strength g due to the sun and radiant flux intensity of the sun. Perfect. So basically, let's say this is the sun. Let's say this is your sun. And let's say this is your probe at a random distance of, distance given है, 1 second. Yeah, distance of x. The distance between the sun and the probe is x. Perfect. This probe measures the radiant flux intensity as well and gravitational field strength as well. कुछ इस तरह से system बना हुआ है हमारा. Okay. For the position of the probe, okay, for the position of the probe when x is what? When x is 1.7 into 10 raised to the power of 11. Calculate g. How can we do that? G is the formula of what? Capital G, capital M divided by R square. What is the value of capital G? 6.67 into 10 raised to the power of minus 11. What is capital M by? Capital M का क्या है? Value 1.99 into 10 raised to the power of 30. 1.99 into 10 raised to the power of 30. What is R? What is R? 1.47 into 10 raised to the power of 11 whole square. Can any genius in the chat calculate the G for me by? G comes out to be 6.14 into 10 raised to the power of minus 3. G comes out to be 6.14 into 10 raised to the power of minus 3. Perfect. Now you have to calculate the gravitational potential energy of the probe. Again. Simple logic. Beta logic लगानी है और कुछ नहीं लगाना. Gravitational potential energy at a formula of what? Negative capital G, capital M, small m divided by R. What is your capital G? 6.67 into 10 raised to the power of minus 11. What is your capital M? 1.99 into 10 raised to the power of 30. What is your small m beta? Small m क्या है? 2.63. Perfect. Multiplied by 2.63 divided by the radius. 1.47 into 10 raised to the power of 11. I would I would advise all of you to do these calculations. इससे ये होगा कि your calculator skills will improve. Your answer comes out to be negative 2.37 into 10 raised to the power of 9 joules. Perfect. Nothing complicated here. Very good, Wahab. Shabash, beta. Chalo, let's further move ahead. Now, this one is an interesting one. And I have already told you guys a trick to prove formulas like this. Beta, in तरह के formulas को prove करने के लिए I have already told you guys a trick. Yep, correct. Moment, your answer is also correct. Show that for any particular value of x, the numerical values of g and f are related by this equation. Perfect. Where m is the mass of the sun, L is the luminosity of the sun, and G is the gravitational constant. So we have to prove this भाई ये क्या चल रहा है यहाँ पे ठीक है. So first of all, if you write the formula of gravitational field strength, capital G, capital M divided by R square, can you visualize one thing? Can you visualize one thing in the final result, beta? Can you visualize one thing in the final result that is too necessary? क्या एक चीज है जो अकलमंद स्टूडेंट्स या ए स्टार स्टूडेंट्स फौरन से रियलाइज करेंगे? इन द फाइनल आंसर यू हैव नो टर्म्स ऑफ आर. In the final answer, you have no terms of r or no terms of radius. Okay. That means what? Okay, you need to substitute this value of r. How will you do that? You know radiant flux intensity is equals to L over 4 pi d square. Perfect. Can I make d square the subject? Yes. D square is equals to L over 4 pi f. Substitute this here. G is equals to capital G capital M divided by L over 4 pi f. Perfect. Take 4 pi f to the top side. G is equals to 4 pi f capital G capital M divided by L is your answer. This is what you had to prove. बस f को आपने यहाँ से हटा के you have to remove it from here and place it on the entire fraction. Simple. Nothing complicated. Let's further move ahead. Okay, what is given by? We are given the graph of gravitational field strength versus F. Perfect. You have to determine a value for the luminosity of the sun. Give a unit for your answer. Now, such an easy question. What will you do? You will say G is equals to 4 pi capital G capital M over L F. Now, if you notice, you have plotted G on the y axis, you have plotted F on the x axis. What is the gradient of this line? The gradient of this line is equals to this function. But the gradient of this line is equals to this little function. Okay. Can we calculate the gradient here? Yes, we can surely do that. One point is what? 0, 0. What is the second point that we can take? कौन सा अच्छा point लग रहा है भाई यहाँ पे? If I zoom in a bit, any points that seem pretty reasonable? Yeah, here we can take this one. ये वाला बड़ा अच्छा perfectly बैठा हुआ है. Yes. This is what? 0.8 and y-axis 4. Can we calculate the gradient here? Yes. Y2 minus y1 over x2 minus x1. What are the units of axis on the y-axis? 10 raised to the power of minus 3. Any units of axis on the x-axis? Yes, 10 raised to the power of 3. What does your answer comes out to be? Can anyone calculate this by 4 divided by zero point 0.8? This is 5. And 5 into 10 raised to the power of minus 6. I hope the gradient is this. I hope the gradient is this. So gradient 5 into 10 raised to the power of minus 6 is equals to which value? 4 pi capital G capital M over the luminosity. You have to determine what? Luminosity. Can we do that? Yes. Make luminosity the subject here. Luminosity is equals to 4 pi capital G capital M divided by 5 into 10 raised to the power of minus 6. Do you know the capital G beta? Capital G की value पता है आपको? Yes, 6.67 into 10 raised to the power of minus 11. Do you know capital M by? Mass of sun पता है हमें? Yep, 1.99 into 10 raised to the power of 30. Multiply it here. 1.99 into 10 raised to the power of 30 divided by 5 into 10 raised to the power of minus 6. Can any genius tell me the answer of luminosity? Can any genius tell me the answer of luminosity? My answer is coming out to be 3.8 into 10 raised to the power of 26. But please confirm it because we have to do the next part with the same answer. Please confirm this answer. Anyone in the chat? यही आंसर आ रहा है नहीं आ रहा? टेल मी. यप, यही आ रहा है बेटा. 3.3 आ रहा है. अच्छा, फिर ज़रूर हमने कोई एरर किया होगा. आई एम गेटिंग 0.3. मोमेंट का यही आ रहा है. फैज़ान का आंसर रॉन्ग आ रहा है. वहाब का भी रॉन्ग आ रहा है. अच्छा, एक सेकेंड यार. व्हाट आर यू गाइज एक्चुअली डूइंग भाई? 4 pi into 6.67 10 raised to the power of minus 11 1.99 into 10 raised to the power of 35 into 10 raised to the power of minus 6. 3.3 आ रहा है for some reason. 3.3 आ रहा है for some reason. 3.3 into 10 raised to the power of 26 आ रहा है for some reason. I think we have made an error in the gradient. I think we have made an error in the gradient. ऊपर 10 raised to the power of minus 3 है. Denominator में we have what? Oh ho. Very good. What an error we have made here. Beta, can you see? Can you realize this fact that two small boxes on x-axis represent what? One increment. This will be 0.6. This will be 0.7. This will be 0.8. This will be 0.9 and not 0.8 by. प्लीज यार इसको करेक्ट कर लो. 0.9 परफेक्ट. इसको 0.9 कर दो. This 4 divided by 9 comes out to be what? 4.4. ठीक है, ये 4.4 आ रहा है भाई. This is 4.4. Perfect. Now you can divide it by 4.4. Your answer will come out to be correct. कर लो भाई वहाब. Do it and tell me answer correct आ रहा है. फैजान, you to do it बेटा. देखो आंसर करेक्ट आ रहा है. Yes, now it is 3.75. Yep, perfect. Now this is your luminosity का answer. Perfect. This is your luminosity का answer. Let's see what do we need further. Use your answer in part C2 to determine the radius of the sun. Now here you need some knowledge of astronomy and cosmology. Here you need some knowledge of astronomy and cosmology. You know that luminosity is equal to what? 4 pi r square into Stephen Boltzmann constant into temperature power 4. What is your luminosity? 3.8 into 10 raised to the power of 26 divided by 4 pi. Okay, you don't know the radius. What is the value of Stephen Boltzmann constant? What is the value of this weird looking symbol here? What is the value of this symbol? This is 5.67 10 raised to the power of minus 8. Perfect. Into temperature power 4. Are we given the temperature somehow here? I remember reading about surface temperature here. That is 5780 Kelvin. Let's take this and take a power of 4 here. 5780 power 4 is equals to R taken under root. Can anyone calculate this answer as well by? R comes out to be 6.9 into 10 raised to the power of 8 meters. R should come out to be this. Perfect. यही वैल्यू आ रही है R की? Yes or no? Tell me in the chat. Yes, are we getting the same values or are we getting different values? Can anyone put in the calculator? Try it out. सर टाइम कैसे लिया है बेटा? टाइम नहीं है ये बेटा, ये टाइम नहीं है. दिस इज टेम्परेचर की पावर 4. क्या हो गया है? दिस इज टेम्परेचर की पावर 4, टी पावर 4. और टेम्परेचर कहाँ गिवन है हमें? वी आर गिवन द टेम्परेचर हेयर इन द फर्स्ट लाइन 5780 Kelvin. तो ये टेम्परेचर की पावर 4 है, नॉट टाइम. भाई टाइम नहीं है ये. चलो लेट्स फर्दर मूव अहेड. अच्छा, डिफाइन स्पेसिफिक लेटेंट हीट. ओके, व्हाट इज स्पेसिफिक लेटेंट हीट? कैन एनीवन डिफाइन? Can anyone define what is specific latent heat? Energy per unit mass required to change the state of a matter at constant temperature. You will say energy per unit mass to change the state at constant temperature. Perfect. Nothing complicated here. Chalo. Let me give you guys a little thoda sa class work. Try this question out. Very easy. Literally one of the easiest question. Part B, I try karo. Very, very easy. Literally there cannot be an easier question than this. You have to show the magnitude of work done on the vapor as it vaporizes. You have to show the magnitude of work done. एक second. Okay, chalo. Let me do it. Let me do it. You have to show the magnitude of work done on the substance when it vaporizes is this. Okay. You have to calculate the magnitude of work done. But work done is what? Work done is pressure into change in volume. प्रेशर की क्या वैल्यू है? 1 into 10 raised to the power of 5. How can I calculate the change in volume? My final volume is 0.017. My initial volume is what? Minus 7.2 into 10 raised to the power of minus 5. Now you can either calculate the answer like this. Or if you are a genius, you can say, sir, this value is pretty close to 0. But this value compared to this value is pretty close to 0. So you can ignore that. You can calculate work done like this: 10 raised to the power of 10 raised to the power of 5 into 0.017 This gives you a value of 1.7 kilojoules. Simple as that. If you take the other approach, still your answer will come out to be same 1.7 kilojoules. Literally कोई difference नहीं होगा आंसर में. Let's read out part 2. What is written in part 2? Use the information in BI to calculate the thermal energy in kilojoules supplied to the substance to cause it to vaporize. Perfect. You have to calculate Q. Do you remember first law of thermodynamics? Do you remember first law of thermodynamics? Yes. Q is equals to change in internal energy plus work done by the gas. What is your change in internal energy? 17.6 kilojoule. What is your work done by the gas? 1.7. Can anyone tell me what the answer will be here? The answer will be 19.3 kilojoules. Literally the easiest question of the all. Use your answer in B2 to determine a value for a specific latent heat of vaporization LV in kilojoules per kg of the substance. Now I can say this ये वाला सवाल थोड़ा सा कह सकते हो कि थोड़ा सा it was difficult. You have to calculate the value of a specific latent heat of vaporization. Okay. What is the formula for a specific latent heat of vaporization? Heat supplied QV is equals to mass into specific latent heat of vaporization. What is the heat supplied? 19.3. 19.3 kilojoules. 10 raised to the power of 3. Do you have the mass? Do you somehow have the mass? सर बाय द गैस से माइनस नहीं होगा. नो बेटा नो. बेटा बाय द गैस है तभी तो प्लस होगा. कैन यू सी योर वॉल्यूम इज इंक्रीजिंग. बेटा इनिशियल वॉल्यूम ये था. नाउ यू हैव दिस वॉल्यूम. यू आर एक्सपैंडिंग. whenever you are expanding you will do what? Whenever you are expanding आप वर्क डन बाय द गैस को पॉजिटिव लोगे. अच्छा फिर मेरे पास कुछ सजेशंस हैं. ओके वेरी गुड. लेट्स ट्राई आउट. So here there is one problem. You don't have the mass. You don't have the mass. How will you calculate the mass? Do you remember grade 8 physics? Mass is equals to density into volume. What is your density bhai? What is your density? Density given hai kahin beta? Yes. 710. What is your volume? 7.2 into 10 raised to the power of minus 5. Now you will ask, sir, why have you taken this volume? Because this is the volume before the liquid evaporates. This is the volume before the liquid evaporates. So I will take this volume. Density that is 710. Density that is 710 into the volume that is what? Volume is 7.2 into 10 raised to the power of minus 5. 7.2 into 10 raised to the power of minus 5. And let's substitute it here. 710 into 7.2 into 10 raised to the power of minus 5 into the latent, into what? Specific latent heat of vaporization. Can you calculate LV? Yes, you can calculate LV by 19.3 into 10 raised to the power of 3 divided by 710 into 7.2 into 10 raised to the power of minus 5 is equals to your LV. What does your LV comes out to be? Any geniuses in the chat? My LV comes out to be 380 kilojoules per kg. Simple. This is your answer, 380 kilojoules per kg. You guys can calculate it as well. Let's further move ahead. The substance in B has a specific latent heat of fusion LF. Suggest and explain. यार अब ये this I have told you in the notes as well, like multiple times, like million times तो बता दिया होगा. Why whether LF is likely to be less, same or greater than in B3? Latent heat of fusion will be less. Latent heat of fusion will be less than the latent heat of vaporization. How many times I have told you this? Fusion will be less than vaporization. Why? You can explain it as well. Because in a specific latent heat of fusion, a smaller volume change is being involved. So you require a smaller amount of energy. Hence, LF is smaller than LV. Perfect. Because in vaporization, there is a big change. You can write this as well. You can write this as well. I am writing the opposite because as we go, or you can say as the substance goes from solid to liquid, there is a smaller change in spacing. There is a smaller change in spacing. Hence, there is a smaller change in spacing. Hence, what will you say? Hence, lesser force or lesser energy is required. Hence, lesser energy is required. And lastly, you can say, hence, latent heat of fusion is less than latent heat of vaporization. Simple. Let's further move ahead. Okay. State three basic assumptions of kinetic theory of gases. What do you have to write here? Three assumptions of ideal gases. You have to write three assumptions of ideal gases. Can you guys write that? Beta, can you guys write the three assumptions of ideal gases? Very good, Wahab bhai. Wahab aaj pad ke aaya bhai. Very good. What will you say? First of all, you will say collisions are elastic. Very good. Collisions are elastic. What will be your second assumption? What will be your second assumption? Anyone else? Negligible intermolecular forces. You can write this as well. Negligible intermolecular forces. सारी आसान वाली लिख लो बेटा, मुश्किल वाली लिखने की जरूरत नहीं है यहाँ पे. Negligible intermolecular forces. Intermolecular forces. And what will be the third assumption? What will be the third assumption? The particle move in random motion भी लिख सकते हो बिल्कुल. One more easy to remember is what? Volume of gas. किसी और ने नहीं 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 नहीं. Moment, this is not an assumption of ideal gases. This is not an assumption of ideal gases. Although this thing is true, but this is not an assumption of ideal gases. Acha. What is your easy to remember assumption? You can say volume of molecules is negligible compared to the volume of gas. Compared to the volume of gas. Perfect. Let's further move ahead. Let's look at part B. Explain how molecular movement causes the pressure exerted by a gas. Okay. How does the molecular movement causes the pressure exerted by a gas? Yes. How will the molecular movement cause the pressure exerted by a gas? What will you say here? The particles collide with the walls of the container. As they collide with the walls of a container, they exert a force. This force per unit area is known as pressure, or this force per unit area results in pressure. So you will say molecules, molecules collide with the walls of the container, with the walls of the container. This causes a force on the walls. This force per unit area gives rise to pressure. Gives rise to pressure. Simple as that, nothing complicated, no big rocket science here. Chalo, let's move on to part C, bhai. What do you have? Figure 4.1 shows the variation with thermodynamic temperature of the mean square speed for two gases. Perfect. So we have mean square speed on the y-axis, we have temperature on the x-axis. Perfect, perfect. Let's see what do we have to calculate, bhai. Okay, we have another graph. Interesting. Figure 4.2 shows the variation with temperature of the product PV of the sample of two gases, where P is the pressure of the gas, V is the volume of the gas. Perfect. So we have two graphs. One is between mean square speed and temperature, and the other is between PV and temperature. Perfect. Oh, we have to state three conclusions about the gases and their samples that can be drawn from figure 4.1 and 4.2. The conclusions may be quantitative or qualitative. Use the spaces below for any working that you need. You have to use the spaces below for any working that you need, and you have to calculate what? You have to calculate or state three conclusions. Okay. What can you do here? Hmm. क्या कर सकते हो भाई? What can you do here? Any ideas? Hmm. If you go to the first figure, figure 4.1, I think this is pretty easy to derive conclusions from. Why? Because if you notice, we have studied kinetic energy is equals to what? 3 over 2 kT. What is the formula of kinetic energy? 1 upon 2 m mean square speed is equals to 3 over 2 kT. Perfect. 2 and 2 will get cancelled out. Perfect. Take mass to the other side. C square is equals to 3k over mt. Can you see this graph is much easier to understand, much easier to resolve because there are lesser amount of variables. This means if I plot mean square speed on the y-axis, temperature on the x-axis, my gradient will be equal to what? Gradient of this graph will be equal to what? Gradient of this graph will be equal to what? Gradient of this graph will be equal to 3k over m. Beta, the gradient of this graph will be equal to 3k over m, where k is the Boltzmann constant, m is the mass of one molecule. So let's calculate the gradient of this graph for line x. Let's calculate the gradient of this graph for line x. That is this line. You have this point, that is x-axis 400, y-axis 5. And you have the second point as this 0, 0 as your origin. Can you calculate the gradient here, bhai? Can you calculate the gradient here? Yep. No, Faizan, you wouldn't say that increasing gradient for both. You have a line. Line ka gradient is constant. You don't have an increasing gradient. You have a line. Line ka gradient is constant. Perfect. Chalo. Let's see this. Now, can you calculate the gradient of x? Yes, you can surely do that. y2, that is 5 minus 0, divided by x2, that is 400 minus 0. Do we have any units on the axis? Yes, y-axis has the unit of 10 raised to the power of 6. Multiply it. What does your gradient becomes? 5 into 10 raised to the power of 6 divided by 400. Your gradient comes out to be 1250. Your gradient is equals to 12500. Perfect. This is your gradient. And gradient will be equal to what? Gradient is equals to it was equals to 3k over m. Yeah, it is equals to 3k over m. So 3k over m. Can you calculate the mass of one molecule of x? Yes. Mass of one molecule of x is 3 times 1.38 into 10 raised to the power of minus 23 divided by 12500. Can you guys calculate this? Answer 3 into 1.38 into 10 raised to the power of minus 23 divided by answer. This comes out to be 3 into 10 raised to the power of minus 27 kg. This can be your first conclusion. The gradient of line x comes out to be what? 12,500. Okay. This gradient is equal to which value? 3k over m. So let's equate it 3k over m. What is k, beta? What is k? 1.38 into 10 raised to the power of minus 23. That is the Boltzmann constant. Bring gradient to this side. The mass of one molecule of X comes out to be what? 3.3 into 10 raised to the power of minus 27 kg. Is this clear to everyone? I am just starting your conceptual thinking again. कल हमने यहाँ पे लीव किया था, right? Yesterday we left here. बेटा ये clear है सबको? Hello, hello, hello. This is your first conclusion. You can write it here. This is very, very important. You can write it here. You can say the mass of one molecule of gas X is equal to what? Is equal to what? The mass of one molecule of gas X is equals to 3.3 into 10 raised to the power of minus 27. Write it here. 10 raised to the power of minus 27 kg. Can I do this exact same thing for line Y and derive my second conclusion? Yes. Let's do this exact same thing for line Y. Let's do it. Okay, so here, chalo, I will have to zoom here. Hmm. Okay, so this point is what? X axis 400, Y axis this thing that is 2.5. Perfect. Now, here is the difference between a genius student and a mediocre student. As soon as I calculate this point, a mediocre student will do this entire hard work again. Yes, 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 Rafe, you are correct. A mediocre student will do all this hard work again. But if I am a little genius, I will know that the gradient of x was 12,500. Can you see y ka point has become half of the x wala point? Can you see the y coordinate of x was 5. The y coordinate of y is 2.5, half of it. So your gradient will also be half, 6,250. This will save you some precious time in the examination. However, if this doesn't click you in the examination, you can calculate the gradient of line y. Very, very easy. You have 2 points, 0, 0 and 400 and 2.5. Let's calculate that. 2.5 minus 0 divided by 400 minus 0 is multiplied by 10 raised to the power of 6. Your answer comes out to be 6250. Perfect. This gradient will be equated to what? 3k over m. Let's do that. This gradient will be equated to what? 3k over m. Let's do that. 3k over m is equals to 6250. Can you calculate the number of molecules? Yes, sir. 3 into 1.38 into 10 raised to the power of minus 23 divided by 6250 is your mass of molecule Y. Can any geniuses put this in the calculator and tell me the answer? The mass of one molecule of Y is 6.6 into 10 raised to the power of minus 27 kg. This is the mass of one molecule of Y. ना ना वहाब क्या हो गया भाई वापस put oh sorry not वहाब Abdur Rafe what has happened to your calculation भाई वापस करो calculation everyone try this calculation out beta you will be getting this as your answer try this calculation you will be getting this as your answer nothing more nothing less you can write it the mass of one molecule of gas Y is Equal to what? Okay, what can be one other conclusion? Hmm. Yes, Fatma, very good. Beta, what can be another conclusion? What can be your last conclusion? Hmm. Yep. What can be an other conclusion? I am getting different gradient. कैसे भाई? Are you perfectly sure gradient different आ रहा है वहां? कैसे हो सकता है यार? How? एक सेकंड मुझे कैलकुलेट करने दो यार. Okay, let me see whether the gradient is coming out to be different or same. No, the gradient is coming out to be same, beta. Wahab, try it again. I guess this answer is correct. Yeah, this answer is exactly correct, bhai. If you are having a issue, this is yes, यही answer है. Okay, what can be another conclusion here? What can be another conclusion here? If you focus a bit, if you focus a bit, here, can you see MV, oh sorry, PV over T? Can you see this second, can you see the second, you can say graph? Can you see the second graph? Yes. The gradient of this graph is equal to what? Change in Y over change in X. What is on the Y axis? PV. What is on the X axis? Temperature. Can you see for both line X and both line Y, your PV over T has a constant gradient? Beta, for line Y, you also have a constant gradient because it is a line. And for line X as well, you have a constant gradient because it is a line. If both of them have a constant value of what? PV over T. If both of them have a constant value of PV over T, that means what? Both the gases are ideal gases. This was the definition of ideal gas. Both the gases are ideal. Perfect. Let's further move ahead to question number 5. Let's see this. Figure 5.1. Show at any moment in time, if you feel there is any difficulty, you just ask away. Figure 5.1 shows a pendulum consisting of a metal sphere suspended by a thin spring. Perfect. The sphere undergoes a small oscillation about its equilibrium position. Perfect. The oscillation may be considered to be simple harmonic. Perfect. You just keep on highlighting the important points. Figure 5.2 shows the variation with time t of the displacement of the sphere from its equilibrium position. On figure 5.1, draw an arrow from the center of the sphere to represent the direction of the resultant force acting on the sphere when it is in the position shown. So basically, we have to mark the direction of resultant force in this scenario. Where will the resultant force act, beta? Where will the resultant force act? Any idea? Do you remember that resultant force always used to act towards the mean position? Resultant force always used to act towards the mean position. So you will draw an arrow towards the left. So you will draw an arrow towards the left. Let's further move ahead. Let's further move ahead. State the amplitude of the oscillation. Again, some notes that I have told you in the class will come in handy here. You have to state the amplitude of the oscillation here. So what can you do here? You can just read it off from here. This amplitude is what? Yes, 0.1, 0.01, 0.012, 0.0. Second. This amplitude is 0.01, 0.001, 0.012, 0.013, 0.014, 0.015. This is 0.016 meters. Your amplitude is 0.016 meters. So you can write it here. 0.016 meters. Now you have to determine the angular frequency. What is angular frequency? W. How can you determine W? Any formulas? W is equals to 2 pi over capital T. Okay. What is capital T here, beta? What is capital T here? 0.4 seconds. Okay. Your time period is 0.4 seconds. Can you determine W? Yes. W is equals to 2 pi over 0.4. What does your answer for W comes out to be? Any geniuses in the chat? 16 radians per second. Now you have to calculate the total energy of the oscillation. Again, very easy. Do you remember the formula of total energy? Total energy used to be equal to what? 1 upon 2 m w square x naught square. Do you have W? Do you have mass? Let's check it out. I guess I saw somewhere the mass of the pendulum. Here we have. The mass of the sphere is 0.15 kg. So you have the mass. Place it here. Do you have W? Yes, you just calculated it 16. Let's place a square of it here. Do you have X naught? Yes, you do have X naught. X naught is what? Your amplitude 0.016. Take it and multiply it here. 0.016 का square. What does your total energy comes out to be? 4.7 into 10 raised to the power of minus 3. 4.7 10 raised to the power of minus 3 joules is your total energy. Nothing complicated. Now let's see what are we required to do again. On figure 5.3, sketch the variation with x of the kinetic energy of the sphere. Perfect. You have to draw kinetic energy versus displacement graph. Perfect. So beta, do you remember at a displacement of 0 at the mean position? At the mean position, kinetic energy is maximum. And what will be the maximum kinetic energy? 4.7. So do we have a point for 4.7 here? Yes, here. And what are your amplitudes, beta? Amplitude क्या है आपका? 0.016 meter. So at the maximum amplitude, that is somewhere here, your kinetic energy will be 0. And negative maximum amplitude as well, you will have a kinetic energy of 0. You draw a graph like this. You draw a graph like this. Perfect. This is your kinetic energy versus displacement graph. Any ambiguities in this question? Yep. Students, is this clear to you guys? Yes or no? Students, is this clear to you guys? Yes or no? Do tell me in the chat. अगर नहीं clear है तो I will explain things again. No worries. Perfect है, clear है. 4.9 नहीं आ रही kinetic energy? No बेटा, kinetic energy is 4.7. Kinetic energy is 4.7. Perfect. Let's further move ahead. Bhai. Let's move ahead to the next question. Okay, state Coulomb's law. Graph, please explain कर दें. Can you give also a... हाँ वो मैं कर दूंगा. Significant figures पे I will do that. चलो. Okay, so graph explain कर देता हूँ बेटा. Graph me at the mean position, at the displacement of 0, at the mean position, at the displacement of 0, you will have the maximum kinetic energy. Here 4.7. At the extreme positions, that is here and here, your kinetic energy will become 0. Simple. This is basic logic that we have studied in simple harmonic motion. At extreme positions, your kinetic energy becomes 0. At mean position, your kinetic energy is maximum. Perfect. Let's further move ahead. State Coulomb's law. What does Coulomb's law state? Force of electric force is directly proportional to the product of charges and inversely proportional to the square of separation between the charges. Electric force is directly proportional to the product of charges and inversely proportional to the square of their separation. Perfect. Let's see भाई next सवाल क्या है. Figure 6.1 shows an isolated hollow conducting sphere that is positively charged. Okay, so you have a positively charged sphere. No, 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 no. Safat, you don't have to write that, beta. No, 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 no. That's incorrect. That will be marked incorrect. Okay. You are given a positively charged sphere and you have to mark electric field lines from this. और बेटा इसके marks कितने? How many marks are you getting for this? You are getting 3 marks for this. Believe me, these are the easiest 3 marks that you will get in A2. What do you have to do? You just have to mark field lines pointing outwards. These are the easiest marks in A2 that you will get. Believe me. Chalo. You have this sort of a electric field line. And if you want to be extra smart, you can also draw diagonal lines as well. You can also draw diagonal lines as well, like this, like this. Perfect. Perfect. Chalo, let's further move ahead. Let's see this. Figure 6.2 shows the variation of the electric field strength E with the distance from the center of the sphere. Perfect. Electric field strength versus distance graph is given to you. Perfect. So what do you have to do? You have to determine the radius in centimeter of the sphere. Okay, you have to determine the radius in centimeter of the sphere. What can be the radius here? What can be the radius here? The radius is the point till where the electric field strength remains zero. Till where is the electric field strength remaining zero? This point. This point is equals to 3.2 centimeter. Your radius becomes 3.2 centimeter. Simple. Nothing complicated here, bhai. Let's further move ahead. Let's further move ahead. 3.2 centimeter. Perfect. Calculate the charge on the sphere. You have to calculate Q, charge on the sphere. How will you do that? Calculate the charge on the sphere. How will you do that? You will go towards the top side and you will note down the electric field at this point. The electric field at this point is what, beta? The electric field at this point is 2.2. What is the R at this point? 3.2. Do you remember the formula? Electric field strength is equals to Q over 4 pi E naught R square. What is your electric field strength? 2.2 into 10 raised to the power of 5. Q is your charge divided by 4 pi. E naught is what? 8.85 into 10 raised to the power of minus 12. What is your radius? 3.2 into 10 raised to the power of minus 2 whole square. Can you calculate the charge? Yes, you can surely do that. Charge is equals to 2.2 into 10 raised to the power of 5 into 4 pi into 8.85 10 raised to the power of minus 12 into 3.2 into 10 raised to the power of minus 2 whole square. Can you guys calculate the charge here? Geniuses, can you do that? The charge comes out to be 2.5 into 10 raised to the power of minus 8 coulombs. Yes, Wahab, very good. Abdur Rafi, very good. Chalo, let's further move ahead. State and explain. State an explanation for the fact that the electric field inside the sphere is zero. Why is the electric field strength inside the sphere zero? Yep. Wahab, we are coming to this point, beta. We are coming to this point. Why is the electric field strength inside the sphere zero? Why is this the case? The most easiest explanation that you can write here is that all the charge, all the positive charge, all the positive charge is on the surface. All the positive charge is on the surface. Hence, electric field, electric field inside the sphere is zero. Perfect. Let's further move ahead. Let's see this. Define the capacitance of a parallel plate capacitor. Okay, define the capacitance of a parallel plate capacitor. Yes. How will you define this? This is a two marker question. What will you say here? You will say capacitance of a parallel plate capacitor is what? Charge on one plate divided by what? Divided by the potential difference, divided by the potential difference across two plates, across two plates. Simple as that. Let's further move ahead. An initially uncharged capacitor X, okay, of capacitance C is gradually charged so that the final potential difference is V and the charge is Q. Perfect. On figure 7.1, sketch the variation with potential difference as the potential difference increases from 0 to V. You have to draw a graph of charge versus potential difference. Do you remember that capacitance used to be equal to what? Charge over voltage. If we take voltage to the other side, this becomes your equation. We have plotted charge on the y-axis, voltage on the x-axis. Capacitance will be your gradient. Perfect. So let's plot a straight line graph here. See, the examiner is giving you 3 marks for this. Wow. Oh, sorry, 2 marks for this. Just for a simple line. How kind the examiner is. How kind the examiner is. You have to just draw a simple line like this. Determine an expression in terms of Q and D for the work done on the capacitor X during the charging process. Basically, the examiner is asking you for what? Energy stored in the capacitor. Again, 2 marks for this. Beta, this is one of the easiest paper, I think. Energy stored in the capacitor is equals to what? 1 upon 2 Q V. Simple. Energy stored by the capacitor is what? 1 upon 2 QB. Simple. And you have to state an explanation for that as well. Explain your reasoning. So, what will you say? Area under graph is equals to energy stored by capacitor. Simple as that, nothing complicated. Let's further move ahead by. Okay, let's see this. We have done this multiple times in classes. Another capacitor Y is initially uncharged. So we have an uncharged capacitor. The fully charged capacitor in X is now connected to capacitor Y. Perfect, as shown. The capacitance of Y is 3C. Perfect, perfect. The capacitance of Y is 3C. Are we somehow given the capacitance of X beta? कहीं पे capacitance of X given थी? Let's see. Yeah, here we are given. The capacitance of X is C. Perfect. So we know that the capacitor X has a capacitance of C. The capacitor Y has a capacitance of 3C. Perfect. Complete figure 7.1. Okay, 7.1. To show the expression in terms of charge and V for the final potential difference and the final charges on both the capacitors. Use the space below for any working that you need. Okay. So you have to tell the final voltage across X. Let me mark them like this. You have to tell the final voltage across X and the charge across X. You have to tell the final voltage across Y and the charge across Y. So how are we going to do this? Any ideas, any geniuses that we have in the chat today? Any geniuses that we have in the chat today? We have studied that the total charge across two capacitors remain same. The total charge across two capacitors remain same. Okay? Total charge across two capacitors. No, 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 not like that. Total charge remains same. What will be your charge before charging? Charge before charging. What will be your total charge before charging. Yes. Your total charge Qt before charging will be equal to what? Capacitance of C multiplied by the voltage across this capacitor X. That was V. With a total charge before charging was what? C V. Total charge before charging was CV. How do you know that, sir? Because before charging, only capacitor X had the charge. Capacitor V was uncharged. See, before charging, only capacitor X had the total charge that can be calculated using Q is equal to CV. Capacitor Y के पास there was no charge. It had a charge of 0. Perfect. Now after charging, what happens? After charging. Okay. Can anyone tell me when will the charging process stop? Can anyone tell me when will the charging process stop? The charging process will stop when the voltage at X is equals to the voltage at Y. The charging process will stop when the voltage at X will be equal to the voltage at Y. Shabash, wow, very good. Can you calculate the total charge after charging? Yes, total charge after charging is the charge at capacitor X plus the charge at capacitor Y. What will be the charge at capacitor X? C multiplied by the voltage at X. Plus what will be the charge at capacitor Y? 3C multiplied by voltage at Y. Do you all agree up till now? अच्छा 1 second. Yes sir, clear है? अभी तक clear है? चलो perfect. Alhamdulillah. Now, can you realize this fact? Can you realize this fact that the charging will stop when the voltage at X will be equal to the voltage at Y? So let me simplify this equation. Let me simplify this equation. CVX plus 3C Vx. I have replaced voltage at Y with Vx. Okay. The total voltage, the total charge comes out to be what? 4C Vx. Simple. This is your total charge after charging. This was your total charge before charging. You can say that. You can say that. You can say that, beta. Okay. Now total charges before charging and after charging are same. Can you equate both of them? Yes. CV, that is this total charge, is equals to this total charge. 4C Vx. C cancel out. V over 4 is equals to your Vx. So your final voltage will be V over 4 for Vx and V over 4 for Vy as well, because the charging stops when both the voltage equal to one another. So you have unknowingly scored 2 marks here out of 3. You will say V over 4 here. You will say V over 4 here and V over 4 here. Perfect. Now, let's see how to find out the final charge. Let's see how to find out the final charge. A very simple trick. A very simple trick. If you have a little brain, beta, if you are a little intellectually correct, you can basically go through A2 physics a paper in half the time. If you see here, what has happened? Voltage for both the capacitors has become same. So if I write this formula, Q is equals to CV. If I write this formula, Q is equals to CV. And if voltage becomes constant, what will happen? Charge will be directly proportional to capacitance. If my voltage becomes constant, charge will be directly proportional to capacitance. The capacitance of X is C. The capacitance of Y is 3C. The total charge is what? Total charge initially is Q. Total charge initially is Q. Perfect. So out of this Q, 3 portions of this Q will go to what? 3 portions of this Q will go to capacitor Y. And 1 portion will go to what? Capacitor X, because capacitance is directly proportional to the charge stored. So you can write here that the final charge on X will be what? Q divided by 4, only getting one portion, and Y will get 3 portion. Your charge on Y will be 3Q over 4. See how easily I did this question, no extra working. All clear up till now? Yes or no? Yep. Sir, please शुरू से explain. अच्छा. How about everyone else? I am confused. Okay, 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 no problem. Sir, charge wala re-explain कर दे बस. Charge wala is for the intellectual ones. Charge wala is for the very few समझदार बच्चे. Okay, let's do it again, भाई. Let's explain it again. First of all, what do you have? You have two capacitors connected in parallel, perfect. Initially, capacitor X is uncharged. Sorry, capacitor X is charged. Initially, capacitor X is charged and Y is uncharged. Perfect. The total charge remains same. The total charge in charging remains same. What will be your total charge before charging? What will be your total charge before charging? Capacitor X has a capacitance of C multiplied by the initial voltage, that was V. CV comes out to be your total charge before charging. How will you calculate the total charge after charging? You know that once the charging stops, the voltage at X will be equal to the voltage at Y. The total charge is equal to the charge at X plus the charge at Y. What is the charge at X equals to? Capacitance of X into the voltage at X plus the what is the total charge at Y? Capacitance of Y into the voltage at Y. We know voltage at X will be equal to voltage at Y. Replace this by Vx. Your total charge comes out to be 4CVx. Equate both of them. You get your final voltage at V over 4. Now let's come on to the charges. You know this equation. Charge is equals to CV. Voltage is constant. So charge will get directly proportional to capacitance. Charge will get directly proportional to capacitance. Now, why? State what is meant by the frequency of an alternating current. Okay, what is meant by frequency of an alternating current? Yes. What do we mean by frequency of an alternating current? Number of cycles per unit time. This is known as what? Frequency of an alternating current. The frequency of an alternating current is known as what? Number of cycles per unit time. Perfect. Let's move ahead. Have I started the recording? Yeah. An alternating current I in the resistor of resistance 680 ohms varies with time according to this equation. Perfect. Where I is the current in ampere, T is in seconds. Show that the period of the alternating current is this. Okay, we have to calculate the time period. How will we do that? We know that this 40 pi is equals to what? W. W is equals to 40 pi. 2 pi over T is equals to 40 pi. Pi pi cancel out. 2 over 40 is equals to your time period. Your time period comes out to be 50 milliseconds. Nothing complicated here. Literally easiest thing. Okay, chalo. Now let's further move ahead. Now let's further move ahead by. On figure 8.1, sketch the variation of current with time t between t is equal to 0 and 100 millisecond. We have to sketch the variation of current between time t is equal to 0 and 100 milliseconds. How will we sketch this graph? How will we sketch this graph? Very, very easy. Current is equal to 3.5 sine 40 pi t. Perfect. So, what is the maximum value of current? What is I naught? 3.5. What is the time period? Time period is 50 milliseconds. Your maximum value is 3.5. That is 3.5 will be where? If this is 3, this will be 3.5. Let's say you have a maximum value of 3.5 here. Zero current at time t is equals to 0. At 25 milliseconds, you have again a current of 0. Then you have a current of negative 3.5 ms minus 1 here. Then again a current of 0 here. Can you plot a graph between these points, bhai? Yes, you can do that. Like, yeah, gap ka graph. This is your graph. You can replicate it for one more time because we have to draw a current variation for time t is equals to 0 till 100 milliseconds. बेटा is this clear? ग्राफ किस तरह बना है? Everyone, फातिमा, अलेहा, बच्चों, is it clear? You have to obviously replicate it one more time as well, but I am not replicating because this will be just common sense एक और दफ़ा replicate करना. ठीक है? अच्छा, which year we are doing? बेटा we are doing October November 2024 paper 4 variant 2. लास्ट सवाल है ये आज फिनिश कर. ठीक है? Determine the root mean square current in the resistor. We have to determine IRMS. IRMS is equals to what? I naught over under root 2. What was your I naught? 3.5 divided by under root 2. What does your current RMS comes out to be? Current RMS comes out to be 2.5 ampere. Simple as that. Use data from B, including your answer in B3, perfect, to show by calculation that the mean power in the 630 ohm resistor is half of the peak power. भाई आपने शो करना है. मैं समझा देता हूँ बेटा, डोंट वरी अबाउट दिस, अभी इसको देख तो लो पहले. नाउ वी हैव टू शो दैट द पीक पावर का हाफ इज योर मीन पावर. फर्स्ट ऑफ ऑल लेट्स कैलकुलेट द पीक पावर. हाउ कैन यू कैलकुलेट द पीक पावर? द पीक करंट का स्क्वायर इनटू रेजिस्टेंस. व्हाट इज द पीक करंट? 3.5 का स्क्वायर. व्हाट इज द रेजिस्टेंस? 680. Let's calculate the mean power. For the mean power, you will take the current RMS ka square multiplied by the resistance, that is 680. 2.5 ka square into 680. Can you guys calculate the peak power and the mean power? Peak power comes out to be what beta? 8330 volts. Yeah, आ जाएगी 8330 volts. What will your mean power come out to be? Mean power comes out to be 4170 volts. So approximately they are half of each other. Approximately you can say, you can write it here. Mean power is half of power at peak. Simple as that, nothing complicated here. Let's see this. Clear? Chalo, good. Electrons are accelerated in a vacuum from rest. Perfect. So electrons are accelerated from vacuum in rest through a potential difference to form a beam. The electrons each have a mass of m, charge of q. Okay. The beam is incident on a graphite crystal that acts as a diffraction grating. After passing through the crystal, the beam reaches a fluorescent screen. An interference pattern is observed on this screen. Explain what this observation shows about the nature of particles. बेटा अगर आपके electrons are diffracting, they are interfering, this tells us what? Electrons are behaving as what? Waves. Electrons are behaving as wave. So you can say, uh, you can write it like this: diffraction is a characteristic of waves, and since electrons are diffracting, they are they are behaving as waves. They are behaving as waves. Perfect. Determine an expression in terms of mqv for the momentum p of an electron in the beam. Perfect. We have to determine an expression for momentum in terms of mqv. So, do you remember whenever electron is accelerated through a vacuum, which formula or which energy conversion do we use? We say kinetic energy is getting converted into electric potential energy. What is the formula of kinetic energy? 1 upon 2 mv square. What is the formula of electric potential energy? Voltage into charge. Now here, beta, if you analyze, मैं ये trick first paper से discuss करता हुआ आ रहा हूँ. Can you see you have no variables of velocity here? Can you see you have no variables of velocity here? That means you have to somehow substitute velocity here. Okay. You know momentum is equals to mv. Momentum divided by mass is equals to velocity. Substitute this momentum divided by mass here. 1 upon 2 m into m like this voltage q. 1 upon 2 m into momentum square into m square is equals to vq. M cancel out. You have to calculate an expression for momentum. Momentum is equals to 2m vq under root is your answer. Simple, nothing complicated. Literally, सबसे easy सवाल. You just have to tell the derivation. Let's move ahead. The potential difference through which the electrons are accelerated is now increased to a greater value. So basically, what are you doing? You are increasing the value of V. Perfect. Describe and explain the effect of this change on the interference pattern observed. Beta, if you increase the voltage, what will happen? If you increase the voltage, what will happen? You remember this, lambda is equals to H over P. If you increase the voltage, if you increase the voltage, your momentum increases, your wavelength lambda decreases. Your momentum increases and your wavelength lambda decreases. If your wavelength or lambda decreases, what will happen? Your fringes will move closer together. बेटा notes में भी ये मैंने बात पढ़ाई थी. I don't know how many of you remember. वैसे तो I have very less hope कि you will remember. Let me show you कहाँ पे थी ये. Yeah, एक second. Let me show you कहाँ पे थी ये बात. If you basically increase the voltage, what happens? If you increase the voltage, higher accelerating voltage, your fringes gets closer. आपकी rings बेटा close आ जाती हैं. So you will write it here. You can write this answer here. For 2 marks, what will you say? As voltage increases, momentum increases. As momentum increases, wavelength decreases. And as wavelength decreases, fringes come close together. Fringes come close together. Perfect. I don't think there is any complication here. बहुत simple सी बात है. चलो, let's further move ahead. Now you have to sketch the graph of momentum versus 1 over lambda. Now this is an interesting graph. This is an interesting graph. बेटा what is the relationship of very easy यार. वहाब क्या हो गया है? आज पढ़ के नहीं आए हुए. बेटा दो फ्रिंजेस के बीच के डिस्टेंस को क्या कहते हैं? दो वेव फ्रंट्स के बीच के डिस्टेंस को क्या कहते हैं? वेवलेंथ. If your wavelength decreases, fringes will move closer together. Yes, basic A level physics. Sorry, AS level physics. क्या हो गया है तुम लोगों को? Now, this is an interesting graph. You have to draw a graph of momentum versus 1 over lambda. Hmm. Now, most students क्या करेंगे यहाँ पे? वो बहुत ही जज्बाती होते हैं. Students of A to AS level are quite emotional excited. They will draw this and they will get a 0 in the face. Why? Because you have failed to realize you have to draw a graph of momentum versus 1 over lambda. Momentum is what? If I, yeah, do it like this and then I separate the terms. Momentum and 1 over lambda are directly proportional, not inversely proportional. You will have a graph that is passing through the origin like this. Perfect. State the name of the quantity represented by the gradient of this graph. Planck's constant. Planck's constant. Literally easiest marks in A2 by इसीलिए you must aim. Let me tell you, all of you must aim for at least 80 to 85 marks in P4. Easily आ जाते हैं. There is no big deal if you practice enough. Let's move on to the next one. Radioactive decay is both random and spontaneous. State what is meant by random. अच्छा random का मतलब क्या होता है? In radioactive decay, what is meant by random? We cannot predict which nucleus will decay next. We cannot predict which nucleus will decay next. Okay? We cannot predict. We cannot predict. We cannot predict which nucleus will decay next. Okay, what is meant by the term spontaneous? What is meant by the term spontaneous? Acha, what is meant by spontaneous? Some things we have to write according to the marking scheme. It is not affected by external environments. Not affected by external environments. It is not affected by external environments. Simple. State one piece of evidence for the random nature of decay. Okay, you have to state one piece of evidence for the random nature of decay. Bhai. How can we show that radioactivity is random? One piece of evidence that radioactivity is random. Anything. You will always notice fluctuations in count rate. Fluctuations in count rate. Let's move on to the last part. Describe the differences between nuclear fission and fusion. Now tell me, is this an A2 level question? बेटा ये तो O levels और IGCSE physics में पूछा जाता है. The differences between nuclear fission and fusion. ठीक है. Now, what can you write here? वैसे it's such a boring question that I am not even interested to do this. Nuclear fission and nuclear fusion. You can tell in the chart as well, bhai. Don't be so dumb. Tell some differences. What will be the differences here? First of all, nuclear fission involves what? Breaking of larger nucleuses into smaller nucleuses. In nuclear fission, we involve what? Larger nucleus break down into smaller nuclei. For nuclear fusion, what happens? Smaller nucleuses fuse into larger nuclei. Nuclear fission is a chain reaction. Nuclear fission is a chain reaction. This is not a chain reaction. Not a chain reaction. The third difference, let me see in the chart. Do we have any geniuses? Fission when two, ठीक है, we have written this. ठीक है, ठीक है, ठीक है. We have written this difference. Third difference, anyone? Anyone who can think out of the box, भाई क्या होगा? Yes. Fusion usually occurs at higher temperatures. Fusion usually occurs at higher temperatures. And fission की ऐसी कोई requirement नहीं होती. Or you can say it like this. Fission is initiated by a fast moving neutron. Whereas for fusion, you require what? You require high temperatures. Let's move on to the last one. Explain with variation of binding energy per nucleon with nucleon number why the processes of nuclear fission and fusion both result in a release of energy. What a beautiful question. Why do the processes of nuclear fission and fusion both release in a release of energy? भाई ये fission और fusion के processes, why do both of them involve a release of energy? Hmm. Yes. What can we do here? Hmm. What can we do here? Beta, do you guys remember a graph that I told you guys? Do you guys remember a graph that I... Oh, do you guys remember a graph that I told you guys? Somewhat like this. Do you remember this graph? Binding energy per nucleon on the y-axis and nucleon number x on the x-axis. What did I told you? Every nuclei in this world is trying to reach the highest binding energy because the highest binding energy per nucleon is the most stable. Okay? Highest binding energy per nucleon is the most stable. Now, in both fission and in fusion, there is an increase in binding energy. In both fission and fusion, there is an increase in binding energy. In both fission and fusion, there is an increase in binding energy as nuclei are trying to reach higher binding energy per nucleon. Higher binding energy per nucleon. In both fission and fusion reaction, iron is more stable. Perfect, perfect, perfect. In both fission and fusion reaction, both of the reaction increase your binding energy because all of the nucleuses are trying to reach higher and higher binding energy. This is the reason. This blue region is for fission reactions. This yellow color region is for fusion reactions.